First things first, I want to assign chapters 8 and 10 in your Mortals book. And along with that, a ticket for 3 questions out of those chapters due Tuesday.
So 8 and 9.
8 and 10.
8 and 10.
Questions each chapter.
3 questions total. Preferably 1 from each. In addition to that, since your pens are up, a week from today, that terminology worksheet that is on the website, let's go there real quick. The terminology worksheet, this one, I've been suggesting that you work on it all along while you do your reading, and as we talk in class, let's make that due a week from today. The ERD practice is also coming down the way here, so let's talk about that one. Got the worksheet, which shouldn't be too bad. ERD practice, we're going to learn how to do the rest of it today. I'm going a week from today on that one too. A lot of it, many of you have already tackled. It's just a matter of polishing it up. The ERD practice with all the cruises and that stuff is also due a week from today. All that's in Blackboard as well. Last time we left off having worked most of what we're going to do for the entity relationship diagram steps, actually all of what we're going to do with the entity relationship diagram steps. So I'm going to the PC Clinic here as our example again. Maybe. Okay, so last time we talked about all of these relationships, and I struggled a little bit with services, issues, and parts. And so let me propose something a little new to you today to maybe resolve that issue. But before I do, any questions on the ones, the M's, did record it last time so you can listen to the thought process. Remember, when you're determining these cardinalities, you start with the word one. One technician can provide many services. So that's where the M, that M comes from. One service is provided by many technicians, potentially. And that's something I'm going to change today. Just remember that when you're building these things. What I'm going to add today are 3 tables that I call validation tables. Sometimes they're called lookup tables. Their only purpose in life is to list an approved list of parts. We talked about what's a part, right? And my answer to you last time was a part is a piece of RAM with a certain serial number on it, or a hard drive with a serial number on it. That's a part. specific serial number. But what I'd like to add to this today is the ability to look up RAM, hard drive, video card, those kinds of things. The type of part is what I'm envisioning here. So I'm going to add a new table called TBL part types. What the part types has in it is just a list, a very small table that has in it a list of the types of parts that we typically install. That way somebody isn't typing in video card with a space while somebody else types in video card without a space. So it's a validation table, or it's a pre-approved list of parts. Doesn't mean we're necessarily fixed to that when we get to the front end of this. The GUI could say, here's a list of parts, pick one, you pick one, or if it's not on the list, you can type your own. And then what the GUI would have to do when you hit save is go, oh, that's a new part. Let's add it to the parts table. So the next time somebody looks it up, they see that new part. So these are part types. Think RAM, think video card, think hard drive. Just a list of hardware, really. So one of these part types could be the part for how many different parts. Now we're still into serial numbers down here. That's a many relationship. But one part with a serial number only refers to one part type. So if I'm looking up a part and I'm documenting the fact that I'm going to use the stick of RAM, I'm going to call it RAM. I'm going to look up the fact that it's RAM. We're not going to call it random access memory. We're going to call it RAM in our clinic. Or random access memory, probably one, but not both. Because if I ever want to do a search or statistics on how many sticks of RAM have I installed, I don't want to have to search for RAM or random access memory or whatever other combinations of those we can think of. There's only one, hopefully. But every time I install a part as part of my service, it refers to that. It also refers to the manufacturer. So Kingston would be up here. It's Kingston, RAM, and then there might be more fields, different information like what type. We might include that. We might include different types of RAM like DDR4 and I don't even know what they are anymore, but all those fancy things. Who knows? That gives us some flexibility and also gives us some more integrity. Less likely to have overlaps if their list pops up and says pick one of these types. Now I want to do the same thing with issues. There could be issue types like virus, like computers running too slow. We could have an issue types table. This issue then resolves itself a little bit differently. Remember what I said the end of last hour? Remember, you see how easy this is? It's not. And I'm still struggling with this issues thing. Remember, this little triangle here was causing me grief. This service, what is a service? To me, it's a services. Let's tweak this one first. This is my current thought process, and these are the things that hit me a little bit later. And let's make a little room over here. What's this hanging out here? Payments. Customers, looks like they're just doubled up. So here's the services, like blow out the computer, like install RAM, like run virus scan, run crap cleaner, CCleaner, excuse me, whatever. Okay. Those are the types of services. Over here, these are going to be services performed. Service performed is one service that we performed, like on a certain date, like run the antivirus scan. When did we do that? On this work order. This is the types of services. I notice I didn't put the word types on here. I could. This is just the names that I'm coming up with. If you want to be consistent and call this service types, you could. But I like the performed here because it helps us remember that this is stuff that we're actually doing. These are the categories, if you will, or the services that we provide. And again, one service like run the RAM could show up as many times, but this service that I performed only refers back to one of these. That should help. But I think it also redefines this. And maybe this relationship. This is one service that I performed. One work order could have many services, but a service that I've performed, I cleaned RAM, only refers back to one work order. A technician can perform many services, but a performed service, cleaning out the RAM, is probably only going to be done by one technician. I don't imagine that I'm halfway through the virus scan, so I'm walking away and now it's your job. We'll just tag that to the person whoever started it. And so what happens, what we've come up with here is a linking table. The services performed is a linking table. Notice how many times it's a child here. Oh my goodness. All right. So in this services performed, we'd have information about what service did you perform? Who did that service? Did you use any parts? Which issue did this resolve? And which work order was it related to? Remember how I said that in many databases, there's often one table that's kind of Grand Central Station here. And what's really weird about this one is the one that looks like Grand Central Station to me is a child to everybody else. Usually that Grand Central Station is a parent to lots of other people. Here it's almost the other way around. Remember those 20 databases that you have to get with experience? This is one of the first ones I've seen in my 17 that has a central table that is a child to about 800 other people. Okay, 5, 6. Miguel?
I was wondering, so it's okay to have like a triangle relationship then between several?
It's okay. It's not my favorite thing because it can cause some issues. But the reason we have a triangle here is we can perform services that are not related to issues. They didn't tell us that the computer's overheating, but as part of our typical customer service coming into the clinic, we're going to blow out the dust of your computer so that you don't have overheating problems. So there are some services that are not related to issues. Now, one work order can have many issues on it. An issue is on many work orders. What that tells me is that there's another issue type here. I don't like this one, this many to many relationship. You have to resolve it, right? Well, in this case, the problem is not the resolution, it's my definition of issues. I mentioned that last time too. Sometimes you, the database administrator, or you, the database designer, have to understand what's an issue. This, to me, I think is a linking table. And what we're missing here, once again, is the issue types. What types of issues normally come up? My computer's running too slow. I'm infected with a virus. That's an issue. Go ahead, Joni.
My thought process on the work order issue. When you have a work order, there could be many issues listed in that work order. But when you do it the other way around,
One issue?
Issues would probably be more singular.
Well, they're never singular, okay? But when we talk about this, we talk about one issue.
Yeah, it could be many work orders.
Right? But if the issue is my computer's slow, how many work orders could that be related to? Right? But this is the issue type, is really my computer is too slow. That's what we're talking about. That's what I see here now, the more I think about this. And again, thanks to Lyle for bringing this beast in and making me look like I don't know what I'm talking about. Bottom line is, when it's a new database, you don't usually know what you're talking about. This is what you have to figure out, and as a team, we have to figure out what are we really talking about. So once again, issues here. This issue is an issue on a single computer, or a device issue, or a work order issue is what some people will do. So rename this TBL work order, and that's an ugly name, right? Work order issues. So for this work order, what issues do we have? Here's a list of approved, at least to start with, issues, like computer too slow or running too slow. Are those the same thing? Probably. Do I want them entered in 3 different ways in my database? No. And that's where these issues are coming from. One issue type, like computer running too slow, could appear on many work order issues, but a work order issue is only for one type. A work order issue only refers back to one work order because it has the word work order in it. And so what's happening here is whoever brought up the fact of issues actually put in what turned out to be a linking table already. Karen?
My problem with issues is it seems to conflate 2 different types, the symptoms and the diagnosis. So if you're so the issue on the work order may be computers running too slow.
Okay.
And that's a symptom.
Yes.
But the diagnosis might
That's my service. It's my solution to
so the
that.
diagnosis is
So if you want to rename that symptoms, okay, we could do that. We could put symptoms in, but yeah, issues, symptoms, what's wrong with your computer is what I'm talking about here. So to answer Karen's question, I think these are the symptoms. This is what the customer is telling us is wrong with their computer. And then we perform services to hopefully resolve that. And it might take a multiple of services. This work order issue could have many services performed to it. But one service, like cleaning RAM, like installing RAM, the reason we're doing it is because of this one work order issue. The computer's too slow. Phew. Let me see how well my connections go here. The connections are great, but oh my goodness, my ones and manys are all over the place. What I'm trying to do is make this a little easier to read, failing miserably. Now I've kind of avoided my crossing lines, and I can clean this up a little bit, and now all my 1s and M's are floating around haphazardly. So one work order can have many, but the service is only for one work order. One work order can refer to one issue. This is all stuff we've already done just by moving stuff around here. I've lost my M's. There are ways to group these things, so when you move one, the other goes with it, but it's not real easy to do. One work order can have many work order issues, but a work order issue is only referenced back to one.
How do you do that little curvy thing when the lines cross?
It did it automatically. Still an M. I think this M belongs over here. One work order issue can have many services to resolve it, right? My computer is running too slow. Potentially, I could do the virus scan, clean out all your viruses, computer's still running slow. So I might perform another service like installing more RAM. Now your computer is running faster. Or I might run another service, and that's to run one of the cleaner programs. So I think this will handle things, but what's interesting to me here is it sounded simple coming in, right, Lau? It sounded simple coming in. But if we really want the flexibility, it gets a little more complex. Questions? We're going with this. That's what I said last time. But we're going with this. If we find errors in the future, that's not uncommon. We'll resolve them as we go along. What we now need to do is for every table, for every entity, determine its primary key. Typically, the primary key is what's called an artificial key or a made-up key, which is called an auto number field. In most database programs, including MySQL and Access, the two that we're going to be looking at, there's the opportunity to create an auto number field. Every time you create a new record, the database program automatically assigns it a value, the next available value. That happens automatic. That ensures that every record that you add to your database has a unique value that we can then use to refer back to later. We want to use them for lookups and we want to know what did we pick. Most of my fields, most of my tables, use auto number fields as their primary key. So that's what we're going to do here as well. We could look into a table and say, does it already have a natural primary key? Problem with most natural primary keys is occasionally they change. And if they change, it's very difficult to make the change throughout the database. What auto number fields allow us to do is define an arbitrary number to assign to something. That way, if its corresponding data entry changes, we can change it, and the rest of the database doesn't care. We don't have to change anything anywhere. I'll show you this as we go. The downside of auto number fields is that there's very little referential integrity. Remember, making sure there's no duplicate, I'm sorry, not referential integrity, but that there's no duplicate records. If you use auto numbers, there can't be a duplicate record ever because of primary keys. Can't happen. The database will not allow it. Many database programs don't let you edit these auto number fields. They generate the numbers. You can't change it. Why would you want to? It's an arbitrary number. You can't change it. I was surprised to find out that MySQL, we can change the auto number field numbers. Doesn't make any sense to me, but we can do it. So the downside here is it's much more difficult to check for duplicate records. And let me qualify that. It's not much more difficult. Maybe just a smidge more difficult. Checking for duplicate records is complicated. What's a duplicate record? You and your name? Not necessarily. You, your name, your phone number? Probably. Not two people with the same name with the same phone number. That's how we can check for duplicates. I already have an Aaron Spate, am I saying it right? Spady in my database with this phone number. Why would I want to add him again? But on the other hand, I already have an Aaron Spady in my database. Is that you? And he'd go, no, never had that phone number. Well, then you're a new Aaron Spady. But if he says yes, it's still me. That's what these duplicate records allow us to do. And I'm getting ahead of myself. They're part of the reading that's coming up. And they're part of the database design that we're going to be doing. The date of each field design, what are the rules? That's one of the hardest things that I've found in previous classes is figuring out how do I sense that this is somebody who's already in my database, that this is a part that's already in my database, that this work order is already in my database. How do I sense that? It can be very difficult. So let's work on these primary keys. Most of these are going to be auto number fields. What I normally do is just take the table name, stick on the word ID. So if I'm coming over here to the part type table, whoa. Inside the part type table, what I do underneath the table name is I put in what I think the ID, what the key is here. I'm going to create a field called part type ID. And we'll put a little star on that. That designates to me primary key. You want to use a P? Go ahead. You want to find a little key picture in the wingdings? Go ahead. But it's a whole lot easier just to type, to me, a star. And after a while, you start recognizing that star means primary key. So this is the name of the table. This is the name of the field. I'm trying to remember if I put them inside or underneath. You know what? It really doesn't matter. The only thing that bothers me here is this might be a little big, so I can highlight it and I'll just shrink it a little bit. That way the table name stands out and the field name is still there, but it's a little bit smaller. Inside, underneath, doesn't matter. Put them in there someplace. Here's my parts table. Probably do the same thing. Part ID. Key. Just about every table is going to work like this. The exception are going to be some of these linking tables that we have, like the work order or the service table. That one's going to be a little dicey. We might change our mind on that one. Might change my mind, let's put it that way. So up here we have manufacturers. Guess what the key is going to be?
Manufacturer.
Good guess. Finally, something we can do that's easy, right? Most of the time, it's easy. What about these? Aren't these just devices? Yes. So the keys for these two are going to be the same as the device because remember these are subtables. This computer is going to have a device ID that matches the device ID up here. This printer is going to have a device ID that matches the device up there. Because they match, I can find the details. I can either find it here or I'll find it there. I will never find it in both, right? Because we don't have printers today that are computers or computers that are printers. This is one of those one-to-ones, and usually in the one-to-ones you share keys. I will never have two printers with the same device ID. I will never have two computers with the same device ID. But the device IDs don't actually come from here, they come from there. It's all Lyle's fault. He picked a database with subtables in. The good news is you'll have this one in your library of here's a database I've designed, and when you do other subtables, you can go back and you can see, oh look, they share keys. Why wouldn't I call this a computer ID? Could, but it really doesn't help me much. Because I still need to be able to link it back to which device are we talking about. So the subtables typically have the same key as their primary table.
So on that one,
Yep.
for the device ID, are we letting that auto-generate, or can we use
Not
like
down
a
here, they're
serial
not.
number?
No, good question. They're not auto-generated down here. They are auto-generated up there.
Only because they specifically identify these.
Only because of the subtables. You can't auto-generate this one down here and that one up there because we'll probably get two different numbers. Because the number of computers is going to be less than the number of devices.
But for the device ID, do we wanna auto-generate that, or do we?
This
wanna
one?
use No, on the.
On this one, yes.
devices. Yeah, do we wanna use the serial number so we know, like when we talked about multiple people bringing in the same piece of equipment?
It's possible, right? I could say that the serial number of a device, because every device has one, is its key. Perfectly acceptable. I'm still going with an ID. Here's why. Serial numbers are really hard to type, especially when you get old like me. I tried to look up the serial number on one of these Macs once. I think the font size is 4. Right? And with my bifocals, I wanted to move the monitor. They're real hard, and I could mistype them anyways because they're huge and long. If I mistype it and discover it later, I've now changed my key. I have to find the corresponding device over here, and that device is also going to show up somewhere else, potentially. Right? And I have to change it everywhere, wherever I use that serial number as a linking field. So my theory here is, just in case it has to change, why would a serial number change? Because I mistyped it. I'm still going to go with an auto number field. We're still going to use a serial number. And we were talking about how do we check for duplicate devices. We check the serial number for devices. That one's easy. If the serial number is already in my database, don't let them put it in again because it's the same one. There was a hand. Where'd it go? Disappeared. Go ahead.
So basically, you just use an auto-generated ID for the primary key, and then it'll just link that so wherever you need.
No, it doesn't link anything. Don't get the impression that this happens automatically. Okay? The linking we haven't talked about yet. That's also part of the process here, is determining how do we link these tables together. And we have to mark our links, our foreign keys, right? Linking fields. We have to mark those. I mark them in the ERD. They also get marked in the data dictionary, which is the next tool that we're going to be using for chapter 8 and 10. And we're not quite done with this ERD. When we're done with the ERD, we're going to have this big picture map of how the database is connected, how the tables in our database connect. But it will not include what are all the fields in the work order table, what are all the fields in the work order issues table, what are all, that's not going to happen. Not here. Happens in a separate document. All right, let me zoom back out here so I can kind of get a feel for where I am, what I still need to do. Those are done. Okay, we should do technicians here. Could we use student ID? We could. But as far as I know, in the clinic, they all have different names. And even if we had two students with the same name, we're just going to, again, assign them this auto-generated number. The primary key's primary purpose is to make sure records are unique, but that's slowly going away. It's now used mostly for linking. And if we're only using it for linking, then it doesn't matter what the number is. It can be auto-generated. So once again, I'm going to create a technician ID. Notice the way I capitalize. It's kind of small, I understand. I'm going to make it smaller. There, even better. Wow, you got that? That's going to be your test. When we get your glasses, we're going to see how that goes. I can't read it either, but there's our technician ID. There's our camel case again. I use it everywhere.
Got the capitalize the I.
Thank you. I didn't forgot. It slipped. Okay. So now I have a technician ID. Down here I have services performed, and notice it's child. That tells me that this is a linking table for all kinds of places. However, linking tables can have this one would have 1, 2, 3, 4, 5 keys. Ouch. I'm not having a table with 5 keys. So once again, I'm going to create a performed, let's make it services, performed ID. Services performed service, thank you. I'm going to do it anyways, because there's going to be too many keys in here if I'm not careful. Does it seem easy? I'm doing this everywhere, right? I haven't broken this rule yet. Are we going to find any circumstances where we break the rules? Yes, but we're not there yet. This one I think is going to break the rules for me. I could create a work order issue ID. I could. And if you want to be safe, I'll probably never mark it wrong if you do. I might question you, say, are we really saving anything here? But in this case, I'm only the child of 2 tables. I'm a linking table between work orders and issues, right? That's the purpose of this, is to link these 2 tables together. So what I'm going to do instead here, I'm going to leave it. We'll come back to it. Each customer gets an ID, and of course when they leave, we give them a card and say, from now on, when you come to your clinic, please bring us your ID. Hell no. No. They get an ID in our database. That's all. We use the ID to link things together. I've left one. Sorry for all the scrolling around here. There's somebody down here. What does that say? One payment can be for many. Oh, we did say that, didn't we? One payment could be for many work orders because I could be paying for my printer and I could be paying for my computer at the same time. Okay. Just questioning myself there. Are you questioning yourself? Go through it. If you got a team, all the better, because if I'd said, no, that's wrong, you could say, no, wait. So here's payment. Do I need a payment ID? Yeah. I think I now have keys for just about all my tables. Well, there is one exception. We're going to see why. But another thing that's happened to me, oh my goodness, dang it. Something else has happened. This database, the way it's designed, no longer has many to many relationships. There's not a single one here that I see. Am I missing it? They're all one-to-manys or one-to-ones.
You had a many-to-many with technicians and
Yeah,
services.
and then I had a technician between services, but what I figured out is that services performed is really my linking table. And so I've screwed this up. Because what's the next step? Resolve your many-to-many relationships. Dang it, I don't have any left. Because we saw these issues in our database, I ended up with my brilliant thought processes resolving them in a different way. So I'm going to have to come up with another example. Before I do, I'm going to save this. And then let's do one more thing though. When you resolve the many relationships, the primary keys are always the keys from the two parents. So this is a brand new table. I started with customers and products. One customer orders many products. One product is ordered by many customers. And so the resolution is to put a table in between. Here's a product that's been ordered. What's the name of the product and who ordered it? One ordered product only refers to one customer. If it's been ordered, my wife just got a set of boots. Right? Boots is a product. They have thousands of them, right? But the fact that my wife ordered boots on such and such a date and it was her is captured in here. This ordered product is for one product. It's for one customer. It ties a customer to a product. It's a linking table. If I want to know who ordered this product, I need to have the customer ID. If I want to know which product is it, I need the product ID. I need them both. Lots of people can order this product. One customer can order many products. So if I want a key that uniquely identifies one ordered product, I have to use the customer product combination. So back to this table. Work order issues. It is really the resolution of this was a many-to-many relationship. One work order has many issues. That's where we started, right? Tell you what. Don't follow. Whoa. There. That was cool. I don't know what the heck that just did. I blew away a table and it reconnected the two parents. One work order can have many issues. One issue type, like too slow, can be on many work orders. So that's a many-to-many relationship. How do we resolve it? Stick a table in between. This work order issues table, notice where the M's are. One work order can have many issues. One issue can be on many work orders. This is a work order issue. For one work order, here's one of the issues. How do we uniquely define that? By using the primary keys from the table, from the parent tables. Combine the keys from the parents. We're going to do another example of this. So in here, my work order issues, I'm going to bring in the work order ID. And I'm going to bring in the issue type ID. And notice they're both keys. This is a two-part key. Two-part keys I can handle. Three-part keys better be a good day. Anything more than that, I make an artificial key. If you had put in here work order issue ID, notice I just have the two keys split here. That would be acceptable. That would be acceptable. Joni?
Are they two different fields then?
Yes. They are two different fields. It's not one field called the work order ID, issue type ID. They're two different fields. And those two fields together, and when you look at this, it's really bizarre because it'll say this work order issue, the work order ID number is 17 and the issue is number 33. What does that mean? We don't know. It doesn't matter. Remember, humans are not supposed to be looking in this database. What this table does is links issues with work orders. 17, the work order number 17 has issue number 33. Which one's work order number 17? I follow the 17 back to here and I get all the details that I want. What issue is number 33? Just come back here, it's right there in the list. Why don't I just put the issue name in here? Because you could mistype it. I mean, we added this to be kind of a lookup table. I'm going to save this. It is done, except for one more piece that we have to do yet. That's determine the foreign keys, the linking fields. When you turn in your practice ERDs, it'll be through step 6. Step 7 says remove calculated fields and constants and then assign fields to other entities. That is not part of your ERD practice. I did not give you a list of fields for what do we store about our passengers. What do we store about our crew members? What do we store about our ships? I didn't give you that. So you can't do it. That's not what they're for. They're ERD practices, so you're going to stop when you get to step 6. But we do need to do step 6. We'll see if we get there today yet, and it's still got a half hour. I might be able to get there. I want to do another couple of examples of resolving many-to-many relationships and drawing ERDs. So I'm going to do another example. My advice to you is sit back and watch this one. I will save it, I promise, and put it on the web so that you can get to it. But I'm going to do a new one. This one's going to be about teachers, students, classes, programs. Programs, students, classes, teachers.
You practice this ahead of time?
Pardon me?
Did you practice this ahead of time?
This is the one I usually do. If it hadn't been for Lyle, this is the one we would have done. But Lyle brought that other one in, thank goodness, because this one's kind of boring. TBL instructors, let's zoom in here so we can kind of see what we're doing. TBL classes, TBL students, TBL programs. Need to connect things. Programs and students are related, right? Directly? You enroll in programs. Yes? Students take classes. I would think so. How about programs and classes? Are there classes and programs? Yes, but that's not what we're tracking. Simplifying. Again, I can make another one like that one we just got done with if I want to make this real. I'm going to simplify the process here. I'm not interested in keeping track of which classes are in which programs. I'm just interested in students and instructors and what that kind of stuff. How about classes and instructors? Yep. Oh, come on, I pressed the magic key. There we go. How about, okay, we said programs and classes. No, how about programs and instructors? Not really. I'm known as a software developer instructor around here, but you know what? I've also taught math. I've also taught Microsoft Office. So does that mean I'm in those they're not even programs. They're gen ed classes. So not really. Yes, I have a specialty, but again, that's not what I'm tracking here. All right, now so that's our basic connectivity. One student has many programs. Okay. Oh, I never did put my M's in there. Let's see if I can steal them from the other one. One student can have many programs. I could simplify this even more, but we need practice with many-to-manys. I will often simplify this and say, no, for the purposes of ours, you're only in one program. You might think you're both a networker and a software developer, but really you're only one at any given time, at some point. But real world, one program is taken by many students, so this is a many-to-many relationship. Cool, we get to resolve it. That's exactly what we want. One student takes many classes. I did not right click. Stop it. Jeez. One student takes many classes. One class is taken by many students. One instructor teaches. God, I wish that weren't true. One class is taught by. Here we are again. We've had this conversation before. What's a class? Programming logic beginning? Is that a class? RDD, is that a class? One instructor teaches many classes, but one class like RDD. Am I the only one who teaches RDD?
No, there are other sections.
There are, ooh, what did he just say?
Yeah.
He just said the magic word. Sections. Keep that in the back of your mind. There's a section in Rapids, right? Programming logic beginning. There's 3 sections, could be taught by 3 different people. That would be painful, but it could happen. So this is a many-to-many relationship, but remember the magic word that Steve said, because it doesn't always pop up. Okay, so now those are all many-to-many relationships. That's awesome. Instructors? What kind? Now I need some keys, right? Because I'm done. Many-to-many, got to resolve those. No, but let's go back. We don't resolve them until we've determined primary keys. Because when we resolve the many-to-many relationships, we need the keys. So we have keys first. Kind of hard to see in that last example. That's why I'm doing this one again. Instructors. I have instructor ID. Should I use my 8-digit ID number? Ooh, this one's tough. I don't know. Should this be auto number or should it be just use the ID number you already have? I don't know. Does it matter? Not really, as long as it's unique. What's the disadvantage to using my 8-digit ID number? Could mistype it, and if we don't discover it for 3 years, we got a big problem. Not likely to happen. So in this case, I might be able to use a non-auto number field because I've already been assigned an ID number. Why would I buck the system? I know that there's no straight answer to that one. Both answers are correct. I can use auto number and then still have my instructor number or MSTC ID or whatever you want to call it. I can do both, but it really gets kind of redundant when we do that. How about classes? Each of our classes already has a number assigned to it. However, I've been around long enough now to see numbers recycled, because we've had so many changes and so many new classes, we ran out of numbers, and so numbers have been recycled, and what used to be 152-101 Programming Logic Beginning is now 152-101 Intro to Web Programming, or whatever. So I'm going to recommend an auto number class ID here because I have experience, and this is where your customers come in, your owners come in. They have the experience. Do you ever recycle class numbers? Yep. How about students? Same logic as instructors, right? You have a student ID. Is that auto number, or is it your 8-digit ID number? Maybe 30 years down the road, we're going to have to start recycling some of your numbers, but right now, 8 digits gives me, what, that's 12 million students. It's going to take a while. All right, that's 99 million students that I can handle before I have to recycle. Don't anticipate it. So we might be able to use your 8-digit ID. Program codes have not been recycled and never will be. All right, so here we could use another already available to us field called program code. Could I make a program ID? Absolutely. But I already have one built into the system, so I'm going to recycle it. Questions about keys? You're never wrong to use an ID. But you can save yourself a little space in the database. You can save yourself a little bit of headache if there's already a natural primary key for a table built into the system. Use it. Now, having said that, our Alliance Camp database, I've got people in that class who are interns at Century, who have been interns at Century, who work at Skyward, who are interns at Skyward and Berkshire Hathaway. And every single one of those companies in their databases uses an artificial key for just about every table. And so, would Century do this? Maybe not. Maybe they'd say program ID. I'm going to go with code just to show you that you don't have to always use an ID. That's the only reason. Okay, so now we defined our keys. That's 4. Step 5 is resolve the many-to-many relationship. How do I resolve a many-to-many relationship? Now we've got some, we can learn it, because unfortunately in our technicians one, or our PC clinic, we screwed that up and didn't get any chance to practice. To resolve a many-to-many relationship, in most cases, there is simply one table in between that you're not seeing. It's called a linking table. Associative table, it's got 6 or 7 names again. Okay, but linking table is the one I prefer. It provides information that combines these two. Okay, last time I checked, Matt, you're in 2 programs, right?
Yeah.
Okay, so where do I put that? Do I allow for 2 programs in Matt's record up here? I'm definitely not coming down here and saying for net fund, here's the 135 million students who are enrolled in the networking program. How many do I allow for here? My wife's got 3 degrees from Midstate. I know John Dunn is in my programming class, in my systems implementation class, and he has his law enforcement degree from Midstate. He's now working on software developer, and when he's done with that, he's going to get his network. How many do I allow for here? The answer is none. It's a many-to-many relationship. There's no good answer. You can't store many in here. You can't store many in there. So the solution is a table in between. I wonder what will happen when I do this. Going to disconnect them and reconnect them? Kind of looks like it, doesn't it? I don't think it did. Oh, no way. Awesome.
Actually did what you wanted.
It read my mind. So much for that. Now the computers can read minds too. Okay. There's a table in between. What do we call that? According to Jason Stroik, who teaches the other information or the systems analysis, the main one, I'm the other, The main systems analysis class, you just take these two tables and you put them together, names. So this is TBL student programs. So let's go with that. Or we could call it TBL program enrollments. Like that better? Yes? Sure. TBL program enrollments. So we make a new table. That was arrow keys in case you're trying to figure out how I did that so quick. Make a new table, and the simple answer is just take these two names and stick them together. Student programs. I wouldn't say program students, though that makes just as much sense, right? This is what's in between there. What are its keys? The keys from the parents. I could say program enrollment ID, but I only do that if I get more than two here. Student ID star, program ID, program code star, both keys. If it ever for some reason needs to go to 3 or 4, then I create an ID. If it's just the 2 in a linking table, I just use the 2 keys from the parents. Copy them in there. Matt in software development. His ID number is in here. Software development is in here. There's another record in this table for, how many Matts are there in here? That Matt. How many times does he show up in my database? Once, I hope. How many times does networking show up in my database? Once, I hope, in this table. But there could be lots of people enrolled, and Matt is enrolled in multiple programs. So in here, there's a record with Matt enrolled in software development. There is another record because he has another enrollment with Matt in software development. There are 2 records. In order for them to be unique, I can't use Matt because he's in there twice. I can't use networking because half of you are in networking, wrong class, but in the systems class, half the people are in networking. So the 2 together are unique though, because he can't enroll in this program twice. He can't enroll in networking twice. Those 2 fields together have to be unique. In combination, have to be unique. Go ahead.
That being considered like a composite key,
Mm-hmm.
because it's both.
They're often called composite keys, compound keys. To me, it's 2 keys. Okay. Now the last part of it, how do we fix these? How do we put these things together? Is you always put the M's in the middle. At least you try. And somewhere on this page I have a 1 hiding. To resolve a many-to-many relationship, you stick a table in between. The in-between table is the child in both directions. And the original tables are the parents. Remember, the parent is the one side of a one-to-many relationship. The child is the many side of a one-to-many relationship. But we really ought to check this. So again, here's the tricky part, checking this. Remember that 1 record in here, in that table, 1 record is Matt in software development. 1 program enrollment. How many students are we talking about? Matt. 1. Good. 1 student can have many enrollments, right? Because Matt's enrolled multiple times. Okay. 1 program enrollment. How many programs are we talking about? 1. Software development. 1 program can have many enrollments. All of you are enrolled in software development. But 1 record in here will never refer to more than 1 program. This record in here is really hard to read, like I said before, because in there I might have something like student number 1, 2, 3, 4, 5, 6, 7, 8, enrolled in program 10152-1. There will never be another duplicate of that because that's one student, one program. I can't enroll him in the same program twice. So that works. In the interest of time, I'm going to tell you this is going to be a mess. So I'm going to do it quickly. This is one of those weird situations, and Steve has already pointed us in the right direction, where if I try to resolve this with a new table in between here, what was that? So much for I'm impressed. Jeez. I guess it wasn't too hard to fix. So what do we call this? This one to me is an enrollment. So that's what we call it when you sign up for a class, right? That's an enrollment. You've enrolled in the class. So I'm going to call this TBL enrollments. Jason's philosophy is just save yourself the brain power and just call it student classes or class students or whatever you want to call it. We're going to put the M's here. And if this were right, and it's not, we'd put the ones on the outside. One student can have, remember what's an enrollment? It's Aaron in this class, right? That's an enrollment. Aaron in this class. One enrollment is referred to one student, Aaron. One enrollment refers to one class, RDD. Now, I apologize to Aaron because I picked on him here. Aaron in RDD. Could that happen more than once? Why?
Because you could fail it this time. and
It's
think it
never
is.
going to happen, not in Aaron's case, right? I hope. But that's a problem. Because if he fails and takes it again, I now have a new enrollment for Aaron and RDD, and that's a duplicate record. The answer is, Steve, what'd you say? Sections. Do you enroll in RDD? No. Do I teach RDD? Am I teaching RDD? No. I'm teaching a section of RDD. And our initial drawing of this did not have that. Steve said it. Often when you go through the field list, you recognize sections as a separate table. But initially we didn't see that. Students sign up for classes, teachers teach classes. No, we don't. I teach sections. So there's another table. You enroll in a section. So now this section that you're in right now is the spring 2015 section of RDD. How many times can you enroll in this room right now at this time? Once. So that fixes my problem. One section refers to one class. There's a relationship here. Classes now become more of a lookup table than anything else. What classes do we have? RDD, Programming Logic Beginning, Programming Logic Intermediate, etc. Here's 20 sections of Programming Logic Beginning. Or a better example might be Written Com. Right over the district, there are 20 sections of Written Com. This is a one-to-many relationship. One section this is not two classes in here. But one class can have many sections. An enrollment is for one section. And we've already said that an enrollment is for only one student. I can't have a single enrollment that has two names on it. Right? Miguel can't say, well, my wife wants to take this class too, so we're just going to enroll together and pay once. That would be convenient, but not good. So what are the keys here? From the two parents, always. That's the easy answer. It is the student ID and the section ID. It's a compound, composite, two-part key. Those linking tables always have at least two. And finally, instructors teach many sections, but one section of a class is taught by, if you want to get technical, we have a couple of team taught sections. So do you want to get technical? Sure, it's only 10 after. So there's a table in between, right? Because that would be many to many. One section could be taught by many instructors. One instructor teaches many sections. What do we call that? A section instructors table. I hate those. It's Jason's answer to that, right? And he's fine with them. It works. It's fine. It simplifies things. But we figured out, because I've done this from year to year to year, that let's call this the assignments table. Because we're not tracking the assignments you do. I have been assigned to this section. I could call it section assignments. Okay. So that it doesn't get confused with homework assignments, right? Section assignments. Now, how do I link them? Two lines in between. Spread them out a little bit so I got some space. I lost my M. Oh well. See, it's still not reading mine that well. Come on, it's close. Go get it. Table in between. M's on the new table. And 1's on the original parents. I'm just control dragging these, by the way. So I'm making copies. Let's make sure that's right, though. Section assignments. Let's pretend that Jason and I are both assigned to this class. And I teach the design and he teaches the SQL. We're both assigned. One assignment is for this section, this class right here, this 11 o'clock section. And for me, the fact that he also teaches it is another record in here. 2 records. Him, this section. That's still only one instructor, still only one section. These linking tables will have multiple assignments. So once again, to finish this up, we have the instructor ID who's been assigned to this section, and we have the section ID for this section. Those are keys. They will not be duplicated because I will not be assigned to this section twice. Won't happen. I can be assigned to the other section of RDD, or I can be assigned to the section of systems analysis, and that'll appear in here. But that's a different course number. It's a different section number. When Jason's assigned to this, he gets his own record, so he doesn't duplicate me. And he won't be assigned to this class twice, but he can be assigned to some other class. So there's duplicate instructors here, there's duplicate courses or sections here, but there's never duplicate combinations of the two. And that's what linking tables do. They tie these two. They show the relationship. This instructor is assigned to that section. This other instructor is assigned to the same section. Those are fairly rare when we have the team taught, but since you wanted a complicated one, there we go. And now every one of my tables has a key. And the point to all of this is to resolve the many-to-many relationships. The point, get my font size right here. The point is to resolve many-to-many relationships. Most of the time, you drop a table in between. If it has a convenient name that you can think of, what is it called when one student is in one program? If you can come up with a good name, use it. If you can't, just combine the two table names. You put it in between. The M's go on the new table. The 1's go on the original table, and you copy the keys from the original tables into the new table. That's how you resolve many-to-many relationships. I've said that kind of quick. It is in my notes. It's also in the recording. That solves the problem. Usually. We got up here and it didn't solve the problem because darn Aaron failed the class, and now I want to have 2 records for him enrolling in RDD. He will still have 2 enrollments in RDD, but it will be for 2 different sections of RDD, because here's the RDD. It's there. Right, but he's enrolling in 2 different sections, and so there's no duplicates. I can tell them apart. He got an F in the first one or a D in the first one, and he aced it the second time around. Because Volker didn't do the PC Clinic example, probably. Didn't confuse him as badly. Many of you are anxious to finish your ERD practice, so let me do a quick overview of step 6. This is the last step that you need to do for your ERD practice. The last thing that I want on my ERD are the linking fields. I want to designate those in my ERD so that I can see them. It's a very important piece of information. How are these tables related? Because we already have the keys, this is relatively simple. What you have to do is make sure that for every child, for every table that is an M side of a relationship, that the parent's key is inside. That's how we link them together. The parent's key field has to be duplicated in the child. Has to be. If it's not, you add it. If it's already there, you mark it. I use an L for link. So, let's use this one, and when we come back on Tuesday, we'll finish up PC Clinic by putting linking fields in there. There probably won't, well, there might be quite a few. So, any table that is on an M side of a relationship. So here's one that's on the M side of this relationship. Is the parent's key, student ID, in here? Yep, it's already there. Since it's already there, all I have to do is mark it. Not only are you a key, but you're also a link. That's the way I do it. If you want another, I've seen some of my students put plus signs in there, and they say that means links. Well, okay, pluses and stars. Hopefully we can keep them all straight, but I put an L in there for link. It's also an M on this side of the relationship. Is the parent key from down here up there? Yep. Designated as a link. So these 2 fields, and this happens all the time in a linking table, the primary keys are keys and they are links back to the parent. Again, in here, we're going to see Matt's record 1, 2, 3, 4, 5, 6, 7, 8. Who the heck is that? Well, I come up here and I look for number 1, 2, 3, 4, 5, 6, 7, 8, and there's only going to be 1. So if I want to know the details, I can follow the link. He's enrolled in 1-152 or 10-152-1. The heck is that? I follow the link back to the parent and say, give me the info. Oh, that's software developer. Okay. That's what the links are for. Because of the links, I can generate reports that say, Matt Daniak, software developer. Am I saying that right, Matt? If I mess up your last names, I'm practicing for graduation, so let me get it right. All right, Spady. All right, good. Daniak?
Danik.
Danik?
Yeah.
Good.
It's like
See why I do this?
CPA.
Right? You can't mess up my names. Don't let me mess up yours. All right, Danik. And then I also have in here, I can write the same report, and it could say Matt Danik, network specialist. Because of the links, I can get the information from 2 different places and stick them together into one report. Enrollments. I got section ID, I got student ID, I just need to put L's on those. They're already in there. Sections is a child. Notice that section is a parent here, but a child here. For every child, here's my child. You got to make sure that the parent's key is inside here. Is class ID in there? No. Now here's the danger. Here's the mistake that you're all going to make. This is not a key. We have already defined all of our keys. This one is simply a link. Its only purpose is to link me back to the parent. It is not a key. We have a section ID that's the key. The class is not part of it. We already have all the keys defined. That's why we do the separate steps. Define all your keys. Resolve the many-to-many relationships and put the keys in. At that point, we're done with keys. All the keys should be defined. Yes, you could make mistakes and you might have to correct them. But if you haven't made any mistakes, you should simply copy the key from the parent into here so that I can go back and say, this is a section of 10.155-1. I think that's RDD, I don't even know. What the heck course is that? Come down here, find the one occurrence of 10.155-1. Oh, that's RDD. Why didn't you say so? Why don't we just copy that up here? Why don't we just, instead of the IDs, because this is not about humans being able to read this stuff. It's about eliminating redundancy. Relational database development. How many sections of that are going to be over time? Hundreds. What if I decide to change the name of the course? I change it once here, and then every enrollment in that course updates automatically because it doesn't have the name in here, it has the ID. Let me finish it. Because you said we have multiple assignments, the keys are already here, mark them as links. But if we took this out and said, no, one instructor per section, period. Then I'd have to have the instructor's ID all the way over here. If I took this out, the instructor's ID would be over here as a link only. I do not uniquely define this section. The section ID does. But if you want to know who's teaching, it's instructor number 1, 2, 3, 4, 5, 6, 7, 8. Go back here, find that instructor and say, oh, it's Volker. Here's his email address. But we put a linking table in between so that solved the problem. So that's what you do. You look at each child in a relationship. Here's the M. I'm a child. Is the parent section ID in here? Yep. Parent's key in there. I'm a child in this relationship. Is the key in here? Yep, it's in there. Mark it. The sections is a child in that relationship. Is the key in here? Nope. Put it in, but don't mark it as a key because it's not.
Isn't it a foreign key?
Yes, but it's not a key. It's not a primary key. She's right. It's a foreign key. It's the definition of a foreign key. It's a field that is a primary key in a different table. I hate that.
So foreign keys are just links then.
That's much better. It's just a link. Foreign keys are links. They are not necessarily keys. Sometimes they're keys, but not necessarily. All right. So your homework assignments, I know this isn't clear yet. We're going to do more on Tuesday. But if you want to start tackling your practice ERDs with physicians and donors and cruise ships, you've at least been introduced to this stuff. Whether you submit it or not is up to you. I think I said the due date's next Thursday, right? Because on Tuesday, I want to do a little more of this, and then you'll have a little more detail, more examples that you could apply. So, you got reading with ticket. I haven't posted the ticket yet, but I will. You have readings, chapter 8 and 10. That's preparing you for steps 7 and 8. And 9, probably. All right. Ticket for that. Got a worksheet. When did I make that due? Thursday? So that you could, we'll answer some of your questions from the reading on Tuesday. Do a little bit more of this. And Thursday, your worksheet is due, because you should have all the terminology by then. Your basic ERD for those practices are due. Questions? That was one long recording.